The following are usually given on formula sheets, but you should know them. It's one thing to look at a formula sheet just to confirm, but if you're actually looking through to find something, then you really haven't done enough practice. So you should know these quite well. It helps to relate your knowledge of differentiation to the standard integrals. We know that integration and differentiation can be considered as reverse processes. If we consider y equals e to the x, we know this differentiates to give e to the x. It therefore follows, since they're reverse processes, that if we integrate e to the x with respect to x, that we'll get e to the x plus an arbitrary constant. We produced this diagram when we did differentiation of sine and cos. Sine differentiates to give cos, which differentiates to give minus sine, which differentiates to give minus cos, and then to complete the cycle, minus cos differentiates to give sine x. If integration is the reverse process, it stands to reason that we can produce a new cycle which goes in the opposite direction. So this is the cycle when we integrate. It's worth remembering this diagram. For example, if you're asked to integrate the cosine of x with respect to x, we can follow the cycle and see the integral is the sine of x plus, of course, an arbitrary constant. If we have y equals the tangent of x, we know that this differentiates to give sec squared x. It follows that if we integrate sec squared x with respect to x, that we'll get tan x plus a constant. If we have y is cot x, it differentiates to give minus cosec squared x. So if we integrate cosec squared x with respect to x, then it follows that we'll get minus cot x plus a constant. Just look carefully at the signs on this last line. If we have y equals sec x, it differentiates to give tan x sec x. It therefore follows that if we integrate tan x sec x with respect to x, that will get sec x plus a constant. And if we have y equals cosec x, it differentiates to give minus cosec x cot x. So if we integrate cosec x cot x with respect to x, it stands to reason that we'll get minus cosec x plus a constant. Once again, look carefully at the signs on this last line. If we have y equals log x, we differentiate to get 1 over x. If we integrate 1 over x with respect to x, we get the log of mod x. The reason we have the mod is that we cannot take the log of a negative number. Logs only exist for positive values of x. Sometimes we don't need the modulus, either because we have a function inside the log, such as x squared plus 1, which can only be positive, or because we're given some range of values for x, which ensures that the function that goes inside the log is positive. For example, here, if we were given that x is greater than 0.